Hey everyone, in this video we're going to learn about the standard form of a line. The standard form of a line is written as ax plus by equals c, where a, b, and c are all integers. Now when we have a linear equation in standard form, we often look to use both the x and the y intercepts to graph. So we need to talk about what the x and the y intercepts are. We'll do that by looking at a graph. So here we have the graph of a line. So our first question, at what point does the given line intersect the x-axis? So we see that the blue line intersects the x-axis, which is our horizontal axis, at the point 2, 0. So our point is 2, 0. And we call this point the x-intercept. It's the point where the linear equation intercepts the x-axis. And then at what point does the given line intersect the y-axis? So our y-axis is the vertical axis. So the blue line intersects here at the point 0, -4. And that's our y-intercept. Okay, so the x and the y-intercepts are the points where a line crosses both the x and the y-axis respectively. And that's typically enough because we need 2 points to graph a line. Okay. Other thing, notice they're points, so we need to make sure we write them with an x and a y coordinate. So if a point is on the x-axis, what must be the y value of the point? Well, let's just draw a general axis, right? So we have x and the y-axis. So if I plot any of these points on the x-axis, each of these points is going to have what y-coordinate? Well, each of these points is going to have 0 as a y-coordinate. So the y value of any point on the x-axis is going to be 0. Similarly, if I plot any point on the y-axis, its x value is going to be 0. Right, so the x-coordinate of any point on the y-axis would be 0. Now we can use these two facts to figure out what the x and the y-intercept of a line is going to be, and then we can use those 2 points to graph the line. So our first example, determine the x and y-intercepts of the linear equation and use those 2 points to graph the line. So our equation is x minus 3y equals -9. So first, we'll start by finding the x-intercept. So the x-intercept is a point whose y-coordinate is 0. Personally, I like to write out this every time. Hey, it reminds me that my answer should be a point and that the y-coordinate is 0. And that's how I'm going to find what the x value of this point is. We can substitute 0 in for y into our equation. So x minus 3 times 0 equals -9. So 3 times 0 is 0. So we have x minus 0, which is just x, equals -9. So our x-intercept is the point -9, 0. Similarly, our y-intercept is a point whose x-coordinate is 0. So we can substitute 0 in for x in our equation. So 0 minus 3y equals -9. So that leaves us with -3y equals -9. Divide both sides by -3. We have y equals 3. So the y-intercept is the point 0, 3. So we can plot these 2 points, -9, 0 and 0, 3. And to ensure I have a straight line, I'm going to use the line tool here. I would encourage you to use a straight edge if you have one. And there is our graph, and I'll label it x minus 3y equals -9. Now, if we want our graph to be accurate, we would probably plot a few more points, but if we have a straight edge, as long as we have 2 defined points, we're going to be able to graph the line. And 2 easy points to find are the x and the y-intercept. Our next example, y equals -x plus 3. So we'll start with the x-intercept. So that's a point whose y-coordinate is 0. So 0 equals negative x plus 3. We can add x to both sides of the equation. We'd have x equals 3. So the x-intercept is the point 3, 0. And then the y-intercept is a point whose x-coordinate is 0. So then we have y equals negative 1 times 0 plus 3. So negative 1 times 0 is 0, plus 3 is just 3. So y equals 3. Our point is 0, 3. We can plot both these points, 3, 0 and 0, 3. Again, I'll use the line tool here. And I'll label the line y equals negative x plus 3. Hey, so just a reminder, the x-intercept and the y-intercept are points. Hey, if I just told you the or if I said graph 3, right, you would have a tough time doing that. There's really no context, where on the graph are you looking, but if I tell you to plot the point 3, 0, I'm pretty confident that you'd be able to do that accurately. Hey, and the other thing to remember is the x-intercept and y-intercept are typically separate points. The only time they're the same point is if the x and y-intercept happen to be the origin at the point 0, 0. Our next example, 4x minus 3y equals 24. So we'll start with the x-intercept. So that's a point whose y-coordinate is 0. So 4x minus 3 times 0 equals 24. So we substitute 0 in for y. Now simplify. 3 times 0 is 0. So we have 4x on the left side equals 24. Divide both sides by 4. X equals 6. So we have the point 6, 0. And then the y-intercept is a point whose x-coordinate is 0. So then we have 4 times 0 minus 3y equals 24. When we substitute 0 in for x, 4 times 0 is 0. So negative 3y equals 24. Divide by negative 3. Y equals negative 8. So 0, negative 8. So applying these 2 points, so 6, 0, and 0, negative 8. And again, there's our line, and we'll label it as 4x minus 3y equals 24. Okay, so this is just an efficient method to come up with the graph of the equation of a line. The nice part about this process is it's going to extend to other graphs that we wind up learning. Okay, this process of finding the x and the y-intercept will always be helpful in coming up with the graph of an equation. Now, we will learn more efficient ways to graph a line, and some you may have seen before, but for right now, if you ever get stuck, if you can find the x and the y-intercept of the equation, you have enough points to graph the line. Now, what happens if a line doesn't have an x-intercept or it doesn't have a y-intercept? What is that line going to look like? So let's take a look. Graph the line y equals negative 3. Okay, so if we think about this line, right, there's no x variable in this equation, so we're plotting all the points that have a y-coordinate of negative 3. So, for instance, 0, negative 3 is one of them, and then 3, negative 3, and negative 4, negative 3, right? Any point that has a y-coordinate of negative 3, we're going to plot on this line. And if we plot all of those points, the line that we would wind up getting is going to look like this. Oh, didn't want it to be dashed. Let's fix that. Line we're going to get looks like that. So that's the equation, or the graph of the equation y equals negative 3. So this is a horizontal line, right? A line that's parallel to the x-axis. So the follow-up question is, what are the x and the y-intercepts? Well, the x-intercept Well, how did we find that? That was a point whose y-coordinate was 0. Well, if I try to find that point, I'd plug in 0 for y, and have 0 equals -3, which that doesn't make sense. So what that means is there's no x-intercept, which we can see graphically. And then the y-intercept, if we were going to find that point, it's a point whose x-coordinate is 0. There's no x variable to plug into, right? Y is always equal to -3. So we would just get y equals -3, which tells us the y-intercept would be the point 0, -3. So let's say we didn't recognize that this was a horizontal line to start, and we went through the process of finding the x and the y-intercept like the previous problems. That's okay. We would just have to understand that in this work here, we would come to the conclusion that there is no x-intercept, there's only a y-intercept, and that happens when we have a horizontal line. And another way to graph this, right, is just come up with a bunch of points, 2, 3, 4 points, whose y-coordinate is -3. Now what about x equals 7? Well, x equals 7, we can do the same thing. Plot a few points that have an x-coordinate of 7. So we'd have 7, 0, we'd have 7, let's say 4, 1, 2, 3, 4, 7, -2, right? Any point that has an x-coordinate of 7. And our graph then would look like this. Right? That's going to be x equals 7. So that's a vertical line. And let's say we didn't recognize that it was a vertical line and we went through the process of finding the x and the y-intercepts. Right? We'd start by trying to find the x-intercept, a point whose y-coordinate is 0. There is no y variable in the equation, so we would just get x equals 7. So 7, 0 is the x-intercept. If we try to find the y-intercept, point whose x-coordinate is 0, we'd have 0 equals 7. That's not a true statement. So then there is no y-intercept. Okay, so what we've come up with in this video is a strategy if we get stuck to graph any linear equation. Come up with the x-intercept, come up with the y-intercept. That gives us 2 points on the line, and from there we can graph. If we recognize a line doesn't have an x-intercept or a y-intercept, we have to realize that it's either a horizontal or a vertical line, and then make an adjustment in our graphing, right? Whether that's knowing it's a vertical or horizontal line, or coming up with a few other points on that line. Okay, so now practice with the strategy is going to be helpful. It extends beyond just linear equations, so that's going to be nice when you see it more in the future.